Hi, my name is Simon, and I'm going to tell you how overloading is the bane of all higher order functions in C++. I have problems, especially in C++. C++ gives me many problems. One specific problem is I have some job I want to do, some function I want to write, and I want it to support a wide range of types. Any type, maybe. Many types. Lots of types. I mean, this sounds like a simple problem to solve because we have templates. But it's actually not so easy if you have some criteria you want to fulfill. So I have two pieces of criteria for this function which I'm going to write. The first one is that I want calls to this function to be succinct. Okay? Some examples. These first two are good. I pass 42. I pass a string literal. Template argument deduction kicks in, works out what the types are. It's all fine. These bottom two, not so good. The third one in particular, specifying this type, maybe this is not easy to work out at this point. Maybe it's impossible to work out at this point. I don't want to have to specify this. I also don't really want to have to construct something to call a function. It's kind of weird. Probably wouldn't pass code review, depending on who you are. Second is I want to be able to pass this around to another function, such as a standard algorithm, and I want that to be succinct as well. So what I mean by this is if I have a std transform, and I can just say, okay, foo is my function I want to transform with. This is good. Again, it's bad if I have to supply a template argument. Might be annoying, might be hard, might be impossible. If I have to construct something to pass to another function, this isn't so bad. So those are my two criteria. Now, the simple solution to this problem is obviously you make it a function template, okay? It's called foo because why not? And it takes a t and returns a t, and maybe does something in between. It doesn't really matter what this function's doing. I only really care at this point about how it fulfills my two criteria, okay? So are the calls succinct? Well, yes, they are, because I can just pass 42 or hello, and type deduction kicks in, it all works. Don't have to supply a template argument, don't have to construct an object. This is what I want. But how about passing it to another function? Well, it's not, at least not in all cases. So if we have a std transform there, then we have to supply our template argument. We cannot pass a function template to another function. It doesn't exist. In some cases, like if we have something which takes a function pointer, the compiler can work it out. But a lot of times we don't have this. We have something which takes some callable object, like std transform does. In that case, we cannot just pass through. It doesn't work. Will not compile. In fact, if we try it, we get this very nice, simple error message. Yay. And this is actually a good error message. This tells us, you maybe can't read it from the back, but essentially just says that we can't deduce unary operation. You know, you passed a function template, can't do it. The function template's not going to work, and it's kind of like if we have an overload set of something which takes an int or a double and returns an int or a double. And in this case, we have the same problem where if we have something which just takes a function and we pass through in, which one do we mean? Do we mean int? Do we mean double? We can't pass an overload set into this function. We don't have that concept in C++. We can static cast it. Who's written code like this? Yeah, lots of hands. We should not have to write this code. Come on. Makes me mad. Anyway, so this is not going to work. So let's go for a slightly different option. We'll take our function template, we'll make it a function object with a templated call operator, okay? Is everyone familiar with how this works? Yep, nods. Okay, so let's look at our criteria again. So we pass this to another function. We have to construct it here, but as I said, that's not so bad. We do this sometimes. You know, if you pass std plus to an algorithm or something, we do this stuff a reasonable amount of the time. And then this is the same overloading version from before, and it works just the same. We just have to construct it. Again, it's okay. But what about calls? No. Remember earlier I said I don't want to construct an object to call a function. So this does not fulfill our criteria. Okay, these are the two simplest implementations of what I wanted to do, and neither of them are doing exactly what I want. And I don't think this is a whole lot to ask, really. Some solutions. Danger quotes. You can do this, but beware. So we could wrap it with lambdas. You know, we have foo, and we just wrap it in a lambda, which takes a t, forwards it on, returns the result. And in some cases, this is okay. In quite a lot of cases, actually, this is okay. It's kind of ugly. We get used to it. We're C++ developers. Yes, Stockholm Syndrome. Okay, so let's look at this lambda. Now, if we're in generic code, okay, maybe we don't know what this foo is actually doing. Maybe this foo is a template parameter in itself, and we don't want to be essentially forcing something in the implementation to do something which it's not supposed to. So what if it takes more than one argument? Okay, we can make it variadic. It's not so bad. What if we care if it's passed an L value or an R value? Straightforward. Okay. But wait a second. How about we care about sphene? We need to stick a decal type on it. And then, what if we care about noexcept? Ah! I don't want to write this code. Use the macro. If I'm giving a talk and I say use a macro, something has gone wrong. So you can do this. You could say, okay, here's a macro for forward, here's a macro to lift this name into an overload set, essentially. So this creates my lambda and does all the perfect forwarding, does the noexcept propagation, does this sphene on the decal type. And then that changes what would be a call like this. We want to write this every time we call std transform, right? And it makes it this. So it is a macro, but I did say solutions in danger quotes, okay? So this is not the end of the world. So let's look for a different opportunity. We had function objects earlier, but the problem was we had to construct them. So what if we just have a global function object? Well, if we have our foo class, which has our operator in it, and then we say in our header file we have an extern const, and in our CPP file then we have a definition for it. No one really wants to write this for every single function, unless you're Eric Niebler. Probably doesn't want to do it either, but so this is not great, but it's a possibility because now we don't need to construct it. We already have one. We can just pass foo, and it works okay. But what if you're header only? if you don't have an implementation file, you don't have anywhere to define that, that global object. So we could make a static context spur, but there are cases where you could pass this around different translation units and end up with different types, and that will break the one definition rule. And breaking the one definition rule leads to undefined behavior. Okay? Actually ill-formed NDR. Thank you, Mikhail. Okay, so in C++17, this is easy. We use inline variables. This is not so bad. If we're not in C++17, we need to do something like this. Don't look at this too long because your eyes will bleed. But this is, if you look at the standards wording, and then you look at the standards wording again, and then you look at the standards wording for a third time, then maybe you can convince yourself that this is actually a way to do this before C++17. Tweet from Titus. In my opinion, if the librarians in your programming language are saying, stop writing functions, use this exotic technique instead, because the language rules are broken, then maybe you want to just consider breaking those, fixing those rules. And he's mostly talking about argument-dependent lookup, which is kind of what this technique of the global function object solves in a lot of ways. Customization point objects, they're called. But it's just as applicable to this situation as well. So let's talk about some actual solutions to this problem. Mikhail's in the front. He wrote a nice paper, lifting overload sets into objects. And so
it was the third paper in the third series of papers I did.
Yes, the third in a series of papers. There were many more papers I could have covered, but I don't have enough time. So you do something like this, say open, close, square brackets, foo. And this will take the overload set named by foo and lift it into a function object, which we can then pass around. So it's kind of like if you'd written this, this lift here. So then, instead of using our macro, which some people will think is janky and weird, then we just use this syntax and it all works. And it kind of, if people get used to this version of doing things, then it seems pretty clear. Some other cool stuff which is in the paper is lifting over operators. It's a very kind of Haskell-y thing to do. You can just take an operator and make it into a function which you can pass around. Or even member data. So you can say you have a user type with a ID and a name, then with some kind of projection function to say like, I'm ordering by some projection, then you could say, I'm ordered by ID. And this is actually really nice, clear code, rather than having to like do a comparison yourself. You just make a function object from this member data and use it as a projection. Committee says no. So apparently this is, there's not enough motivation. I think there definitely is. We use algorithms all the time. Maybe application developers don't care so much about the svna or the noexcept, but generic library authors definitely do. And even application writers, I mean, writing the Lambda, the simple Lambda is not so bad, but we could do better. There are another few reasons why it was rejected, many of which are disputable, but we have what we have. So there's a new paper, which is written by Barry Revson and Andrew Sutton. I think it's probably going to be published for the San Diego mailing, so it's not, you can't go and read it yet, unless you maybe email Barry or Andrew. But it gives this magical type called std overload set. And in a lot of ways, it has, it looks the same as the kind of lift operator in this case, but it has a few other cool things about it. So we can use it here to create an overload set from foo. We can use it to create an overload set from operators. But the really interesting thing, which the paper talks about, is putting it on a function declaration. And so the rules which the paper talks about say if you have this in your function declaration, then when you pass something to this function, the overload set is created implicitly. So you're not having to mark your the actual name you're passing. By virtue of the overload set being in the declaration, being this parameter for this function, the overload set gets created. So this solves some problems with older papers, such as Andrew Sutton wrote one where this would just happen by magic, even if you didn't have an overload set thing in there. In some cases, your name would be lifted up automatically. But there were a number of problems found with that. So this is supposed to be kind of a halfway house. Question in the back, yes. What is F? Oh, that is a very good question. So F is deduced here and has some very complex deduction rules for what it ends up being. So the idea is if this is going to be, if foo is just a non-overloaded function, then F is going to be a function pointer. If foo is like a lambda, then F is going to be deduced to the lambda type. If foo is an overloaded function, then it's going to essentially synthesize some type which represents the overload set, and that's going to be the type of F. So generally, you wouldn't introspect F. Maybe you'd have some reasons to do it, but generally F is just there for the special deduction rules. To answer your question? Great. So those are the main things I want to talk about. We looked at how passing overload sets to functions is really so much harder than it should be in C++. And there are tricks to alleviate it, like using lift macro, global function objects. And there are people on the committee who are trying to fix it, but it's slow going. There's been a lot of papers, there's been a lot of discussion, and it's still not fixed. So if you have any ideas, get in touch with me or authors so that we can improve these things, we can get more consensus, and hopefully we can fix overload sets in C++. Thank you. And yep, make them live happily ever after. So I have some resources if you would like to take a look, and I'll now take some questions. And please use the microphone if you'd like to ask a question. Nothing? Oh, Michal. Oh, dear.
Yeah, so if you could go back to the stood overload set. So this could if you could ignore wanting to know the type of F, or would be fine with making this a having to go type name, decal type, unary op, colon type or something. This could use class template argument deduction, which is I think there's a paper for it for function calls, but the previous slide is slightly more danger zone.
You mean this one?
Yeah, because this how do they want this to work? Do they want overload set to create a special parsing context?
Right.
Ew.
So it's a very good question.
Okay, because you've clearly seen the paper and it's unpublished, so I'm going to poke you about it.
Yeah. So
what is overload set?
Yeah. So overload set is essentially this magic type which the compiler understands.
Is it a type or a type template?
It's a type template.
Okay.
A class template. My guess is that if we ever got something like std overload set, then something like this would probably not end up getting into our final result. Because you're right, it would have to have special parsing just for this type. You would need to know, okay, am I creating an overload set function? And then I need to do this special parsing And so, yeah, that's likely to be very, very contentious when it's discussed. I want to include it here.
Also in the case where
completeness.
you just pass an identifier, you also have to have a special context to kill all their rules for figuring out what's the type of food there.
Yep. So there are, even just doing the pseudo overload set foo up there, you're still needing to do some extra work, but it's a lot less than doing something like .id.
I'm not convinced. It's a lot less work there.
Maybe it's not.
Because that would be the the only, I think, place in the language where you would treat the name of an overloaded function or of a function template as all of those. Well, except of places where you actually call a function through that name, which is significantly different, right?
Yep. Yeah, so this would be, when you call a function usually, then that's when it has to do overload resolution and things like that, and we don't have that concept for just passing a function, a name to another function yet, so this is like a brand new thing. So yeah, it would be certainly implementation concerns, and I don't work on C++ front ends, so I'm not sure entirely how difficult it would be for them.
Do you know if this is going to be in San Diego?
I don't know if it's going to be discussed at San Diego. In the mailing. I would hope it would be in the mailing. I got this version a fair while ago, so it's been worked on for a while, so I'd hope it would be in the mailing. Any other questions? Okay, thank you.